Good afternoon. Thank you for joining us today. My name is Sherry Leese, and I'm the program leader for the Great Plains Fire Science Exchange, and I'll be moderating the presentation today. As you are getting logged in, you might notice a poll down in the left-hand side of your screen on the bottom corner, and we just wanted to get a quick idea of the roles that people have that were interested in the webinar today. So appreciate it if you could just take a moment to identify what category you're in. And it seems as though I've got a lot of people in the other category, so I might need to find out what types of work that you're doing if you're in other. So I don't want to take up much time because I know Casey has lots of great things to tell you today. I just want to mention that if you're not very familiar with the Great Plains Fire Science Exchange, that you can find us on the web. Our address is at the top of the screen. And if you haven't seen our website lately, we did migrate to a new website over the summer. And so you might find lots of interesting things there that you didn't see previously on our website. So we hope you find it useful. And so the Great Plains Fire Science Exchange, our mission is focused around grasslands, and we are acknowledging the private landscape and the importance to conservation. So I'm going to take a quick snippet of the poll so that I can make sure to have that information for later on. And I'm going to go ahead and hide it and get it out of the way. So thank you for answering that. And let's hide it. Okay. And I just want to let you know about a couple of other upcoming activities. We have 2 more webinars scheduled for this winter, one on juniper pollen. I think you'll find that interesting, especially if you know people that have allergenic reactions to it. And then Derek Scasta is going to talk about the effects on hornflies and ticks. And then we'll also be out at the National Grazing Lands meeting in Texas in a couple weeks. And also in Texas, in Corpus Christi, the Society for Range Management meeting will be there as well. All right, so let me just give just a brief introduction to Casey. Casey Olson is a professor of range beef cattle nutrition and management at Kansas State University. His research program is designed to address questions that directly affect the beef industry profitability. Casey, thank you for being with us today, and I look forward to what you have to share with us.
Thank you, Sherry. Am I coming in okay?
Yes, you sound great.
Excellent. Well, ladies and gentlemen, thanks for joining us this afternoon. Before I begin, I'd like to acknowledge and thank the students that were involved in this project, Consuela, Jonathan, Jack, Anna, and Garrett. No researcher gets anything done without quality graduate students. I'd also like to thank Walt Fick. Without his help and without his expertise, we wouldn't have been able to pull this project off. And with that, I'll begin. Most of you are familiar with the Flint Hills and the predominant grazing management practices here, but by my estimate, about 70% of the animal unit months in the Flint Hills are occupied by transient stocker cattle. And the most common system for managing these animals involves annual spring burning in March or April, followed by a relatively short but intense grazing period that is about 100 days long on average, in which all of the year's safe productivity is removed during that short period of time. Steers are graminoid consumers during that short period. 40 to 60% of annual graminoid production is removed, and then grazing lands remain idle for the remainder of the year. Now, annual burning in this system serves to improve stocker gains by about 0.2 of a pound per head per day. It's very valuable from that perspective. And this system as a whole has been tremendously successful over about a 50-year period, with return per hectare and similar total body weight gain occurring relative to season-long stocking. We have a high degree of interest in preserving this system in the Flint Hills of Kansas. Now, into this system has come Sericea lespedeza in the last 100 years. You all know what a bad actor this plant is. In addition to being drought tolerant, adaptable to poor soils, it is also mildly allelopathic, and it's canopy dominant. And it's my personal belief that, in spite of the fact that cultivated varieties of Sericea lespedeza exist in the southeastern United States, what we deal with as an aggressive invader in the Great Plains is a wild type derivative of that plant, much in the way that a domestic pig, when it escapes into the wild, becomes much more robust over relatively few generations. I think that's what we've observed with Sericea lespedeza. It's in fact a feral plant. In addition to the marvels that Sericea has shown us, it's a marvelous reproducer. A pure stand of Sericea can produce 950 kilograms of seed per hectare annually, and that's amazing considering that an individual seed weighs something on the order of a fraction of a milligram. And I think that this reproductive capability has been a key to its invasive qualities, and it's also been it also may prove to be a key to its control. Um, the seed itself, once it's produced and once it's patent, can be transported wide distances, usually with animal or human help. But I think that the movement of that seed has been largely responsible for the invasive qualities of the plant. Now, we've been using herbicides to control Sericea lespedeza for over 20 years, and we have some downside to that control method. Herbicides don't care if they contact a good plant or a bad plant. They're gonna kill everything with a broadleaf. It's also a repeating cost because, in spite of 20 years of repeated use, we have not scratched the surface or achieved anything that looks like eradication. And in the tallgrass prairie in particular, the canopy is so robust that an aerial application in many cases doesn't reach understory juvenile Sericea lespedeza plants. And I think we all know that, in spite of routine herbicide usage in recent decades, the plant is still out of control. In the last 10 years, we've looked at livestock grazing alternatives for Sericea control. Beef cattle avoid Sericea like the plague, probably due to its condensed tannin content. And without extensive dietary manipulation, it's hard to get beef cattle to be significant consumers of the plant. Small ruminants like sheep and goats have a greater natural tolerance for Sericea lespedeza and will consume it in significant amounts, but let's face it, the Flint Hills and the Osage Hills are beef cattle country, and there are significant cultural, logistical, and economic barriers to wide adoption of adding a small ruminant grazing component to an existing operation. Now, I referred to the last bullet earlier. By my estimate, about 70% of Flint Hills animal unit months are occupied by transient yearling cattle. And what that means is that there is no grazing pressure. There's very little grazing pressure in the Flint Hills during the months of August and September. This is critical for Sericea lespedeza management. If we're going to harm it, control it through grazing pressure has to be present. And it has to be present during a stage of growth when Sericea is vulnerable to damage. And unfortunately, we don't have that in our existing system. Now, I'd like to give props to my colleagues from Oklahoma for getting us pointed in this direction. One of our colleagues down there indicated that dormant season spring fires, what we normally do, in other words, may stimulate the growth of Sericea lespedeza by scarifying seeds that have been dropped in the previous fall and now lay on the soil surface. That's a supposition. It's not an investigated hypothesis, but it seems reasonable. An earlier study also indicated that plants that bloom late in the growing season, like Sericea lespedeza, were more harmed by growing season prescribed burns than by prescribed burns that occur during the traditional interval of time, late spring, during that dormant season. Relatively recent finding out of the patch burn work that's been done down at Oklahoma State is that when fire was applied at a 3-year interval in a patch burn system, that the rate of Sericea lespedeza invasion slowed. And these 3 points were enough to get us set on our work. Our objective here was to primarily find a way to work in concert with the transient yearling cattle grazing industry here in the Flint Hills, and to look at a growing season prescribed burn relative to a dormant season prescribed burn as a method or a means of controlling Sericea lespedeza. What I'll be presenting today is the first 2 years of a scheduled 4-year study, and we are very grateful for the support of the National Fish and Wildlife Foundation for this project. Our study site is located in Geary County, Kansas. If y'all have heard of Junction City, it's near there. We got a 125-acre native site there with a heavy historic problem with Sericea lespedeza. Our initial work indicated that basal cover of Sericea was about 2% of all plant life out there, but that only tells part of the story. 2% doesn't sound very bad, but when you look at the problem from an aerial perspective, okay, and how much a canopy dominant plant like Sericea lespedeza would occupy per unit area, the canopy dominance on this site was 36% across the board on all of our individually treated units. This site is grazed. It's used by both yearling cattle and cow-calf pairs during late fall, winter, or spring at the landowner's pleasure. Now, when we moved onto the site, we divided it into 9 roughly equally sized watershed units. We randomly assigned them to one of 3 prescribed fire treatments. Early spring, which we regard as the traditional dormant season burn, midsummer, sometime around August 1st, or late summer, sometime around September 1st. And we established a permanent 100-meter line transect in each one of these experimental units. This is an aerial of our site, and one of the things I guess I'd like to point out with this is that we're bounded on the west and the north by native range. We're bounded by a crop field on the south and east that generally has crops in it while our burns are being conducted. I would not call this a very ideal site to apply these treatments from a fire safety perspective. And some things I'll share with you later would indicate that really hasn't been a problem. Fire safety is actually seems to be greatly improved, in my humble opinion, with a growing season as opposed to a dormant season burn. Now, our rainfall accumulations over the last 2 to 2.5 years are telling. Year 1, 2014, the growing season of 2014, and year 2 would be this past growing season in the purple. The white would be normal for this region. So to summarize, we had one fairly dry year and we had one fairly wet year. On average, we're hitting about the average. But in spite of the fact that we had 2 very different rainfall years, in our data analysis, year was found not to have a significant effect on our treatments. And why that's significant, I'll get to in just a little bit. So we've done this over 2 years now, so all the dates that you see me present are actually averages over 2 years. But our prescribed fires were lit on average the 21st of March, for the early spring, the 1st of August for the midsummer treatment, and the 2nd of September for the late summer. Each year, and basal composition of the site, and on each of our watershed units, we have a permanent 100-meter transect that we read 4 times during the year at 1-meter intervals. We make these measurements immediately before our summer burn treatments are applied,
Casey,
after
are you
each
there?
growing season fire, and then at the end of the growing season as plants approach dormancy.
Casey?
Our primary indices of measurement with this technique are forage biomass,
Casey?
canopy frequency of Sericea lespedeza. Yes.
Casey?
Yes.
Your signal is breaking up a little bit. Do you think you might be having some network issues there?
None are indicated. Can you hear me?
I can. It's just you're fading out at times, so we'll continue to be patient. The other thing that we could try is maybe changing out the headset. Let's try to continue on for a little longer, and I'll give you another signal if it continues to be a problem.
Very good. Is there anything that you would like me to run back and cover?
I think at the beginning of the materials and methods slide, I think you were clear about the dates, and then we were kind of losing you after that.
Okay. So attempting to pick up where I left off, our vegetation transects where we're primarily focused on forage biomass measurement, canopy frequency assessment, crown maturity, and Sericea lespedeza stem height were conducted immediately before our summer burn treatments were applied, immediately after each summer burn treatment, and then at the end of the season as plants approached dormancy. The other measurement that we take at the point of plant dormancy is to measure a number of individual Sericea plants in terms of their whole plant dry weight, and we physically manually strip the seeds off of these plants and count them. We're looking at, all these things together are designed to be an assessment of the vigor of Sericea lespedeza and how it might be changing with repeated applications of treatment. So we're using very simple tools for this latter technique. We have aerial markers of each of our transects. It's just a simple fence post. And then basically what you can't see, the permanence of this transect is delineated by about a 50-pound concrete patio block that we believe will not move. But the measurement tape is stretched tight between the 2 points, and every meter along that tape will take a measurement. Okay, we had to go back to some pretty old school rain science to find a technique to help us assess canopy frequency of Sericea lespedeza. It's basically a visual projection. We're projecting a 12-inch by 12-inch plot 100 times on each one of these transects. We're measuring biomass with a visual obstruction technique there in the right panel, and we're looking for Sericea lespedeza plants in that canopy, one to multiple plants. So I'm not going to bore you with my statistical analysis, but my research sponsor insists that I include it. Take a look at that second bullet. See if I can highlight it here. In the first paragraph, the things that can influence the outcome here are our individual measurement unit, the watershed, our treatment, the time we take our measurement, and the year. And happily enough, through 2 years of data assessment, 2 very different years, year has not proven to be a significant interfering variable on our measurements. Okay, in each case, the treatment by time interaction was significant, so that's the data that I'll be presenting from the vegetation transects. We analyze seed production and whole plant dry weight of Sericea lespedeza in much the same way. However, that's a one-off measurement. We only get to do it once a year, and so time is not a part of that analysis. Okay, now the good stuff, folks. This is day 1, year 1. Our first summertime burn. None of us on the crew had ever conducted a growing season burn. We did not know what to expect. It doesn't seem logical that green grass would burn, but burn it did. Same area just a few minutes later. The fire surprised us a little bit. Tremendously smoky, very slow moving, but all in all burned very, very well. It just was dumb luck that a couple of weeks after we did our first summertime burning treatment, Google Earth did its semi-annual overflight of the area. And from an aerial perspective, the burns appear very complete. You can see the darkened images here. here, and here, indicating the treated watershed units in each location. You'll notice a lot of pathways around each one of the watershed units. Those are mowed fire breaks. We wanted to be as safe as we could possibly be in application of these fires to protect life and property. Now this is a picture of the second year of dormant season fire. This is our spring treatments, and for the warriors on my work crew that burn 5,000 to 6,000 acres a year, this is what we're used to seeing. Okay, that dormant season fire burns very completely, very quickly, and very clean. No residual material to speak of in those burn units. Growing season fires look very different to us. Okay, in the left-hand panel, pasture number 7, where it's indicated there, this is immediately after the fire had swept through on one of our early summer or midsummer burns, rather. You notice there's a lot of standing green material still in that canopy. It looks rough. It looks incomplete. But within about 48 hours, okay, taking your attention to the right panel, all that standing green material browns down and appears to go dormant. So it takes a little time to see the full visual effect of the fire. It's still less clean than a spring fire, but very complete in my opinion. One of the fun things to look at, the unanticipated interesting points to this research, was how hard that growing season fire was, or those growing season fires were on woody stem plants. What you're looking at in the left-hand panel is roughly a 40-foot locust tree, and just a few days after that fire, the trees completely browned down and have since perished. In the right-hand panel, you're looking at a fairly thick patch of smooth sumac. I'll show you another view of that at the end of the presentation. But every one of those plants, although still standing, was reduced to a completely vegetative state. Those woody stems died back almost completely. Now, one of the questions we need to answer with this research is, how does repeated application of a growing season prescribed burn influence critical things like forage species composition and soil cover? We've only got 2 years of that data so far, and we're taking a wait and see approach. I didn't analyze these data statistically at all, but I wanted to give you an idea of some visual trends. Granted, we made these measurements in July, so that may influence how the changes are interpreted. But for our traditional early spring fire, okay, we actually had an increase in percentage of bare soil as a percent of basal area. But with the midsummer and the late summer fires, we actually had a little bit of a decrease in percent bare soil. I regard that as quite positive. In this slide, just like it, we're looking at litter as a percentage of total basal area or soil cover. Again, we see a little bit of a decrease in litter cover from year to year with early spring. See a great increase in litter cover from year to year with the midsummer burn, and a slightly smaller increase in that late summer burn. And granted, these are, I'm making generalizations like greater and lesser. These are just numeric trends. Plant cover, on the other hand, appears not to have changed a great deal year to year or by treatment. Not very much change here. But just to draw a broad conclusion from these past 3 slides, we don't appear to be changing plant cover. We probably are on a trend, at least, to improve or to decrease the amount of bare soil and increase litter cover with our treatments. We don't have a clear idea about how species composition as a percent of basal cover is being influenced, and we probably won't for a couple more years. Now, this slide depicts the effect of our fire treatments on forage biomass. One of the questions that our rancher clients are very interested in knowing is, if I apply prescribed fire after my steers have left rather than before they show up, how is that going to change winter, fall, and early spring grazing opportunities? Now in this slide I've included all 4 of our measurement points. Okay, July 16th before our summer burn treatments are applied, August 8th immediately after the early summer or the midsummer fire, and September 4th immediately after our late summer fire, and then October 9th at Forage Dormancy. Now it's difficult to interpret, a data slide like this. We got a lot of different things going on, but I think it's most instructive to look at pre-fire values and post-treatment values, end of season values here on October 9th. So that's the way I'll be presenting the remainder of the data. Okay, here's that same data set, but this time we're just looking at forage biomass pre-treatment and forage biomass post-treatment. We've got something interesting going on here. If you're not used to looking at statistical notations, okay, every place that there is a B superscript, okay, that means that those means are equal. Every place there is a different superscript, such as here, those means are not equal. So prior to the application of our treatments, all 3 of our treatments were averaging about 6,000 pounds of, or 6,000 kilograms rather, of forage biomass per hectare. If you're used to thinking in pounds of dry matter per acre, the numbers are roughly equivalent. Now with no grazing pressure and no fire, we had a strong uptrend in biomass accumulation on our traditional burn treatments. However, by the point of dormancy, okay, we had replaced all the biomass we'd burned off for the midsummer treatment and then some, and basically got back to par with our late season burn treatment. So pre-treatment, post-treatment values are equal. And from this data, I would make the suggestion that there's very little opportunity here for dormant season grazing opportunities to be eliminated by application of growing season fire for Sericea control. Now, just to give you a visual indication of how rapidly, I guess, that regrowth occurs, in this left-hand panel here, we're looking at roughly a similar area on watershed unit number 8. It was burned on the 30th of August in 2014, and you're looking at it there in the left-hand panel 5 days post-fire. You can see just a little bit of green fuzz starting to poke up through that blackened soil. In the right-hand panel, we're looking at the same area of the same watershed about 20 days after that fire, and you're looking at forage regrowth here that's in the range of 2 to 6 inches. It's amazing how quickly it occurs. And just a few days after that, okay, here in the left-hand panel, I realize my green pointer is a little difficult to see. Okay, we're at roughly a month after our latest fire application, and we've got beautiful looking soil cover here. We've got in this circumstance, about 2 tons of forage dry matter per acre that has replaced itself in that interval of time. Unfortunately for us, okay, that just as easily as that native forage comes roaring back, in the right-hand panel you can see some Sericea lespedeza stems that have regrown off of an existing mature crown. It does regrow after the application of growing season fire. But we think this may be a key to bleeding this plant to death. If you think about it, this invader has maybe been in this ecosystem for 100 years at the most, and its reserves in the seed bank and its carbohydrate reserves in its root system below the soil are going to be reflective of that residence time in this ecosystem. Now, right next door, these native grasses have been here for centuries, and they may have a deeper reserve, a deeper tolerance to handle that growing season interruption in their growth cycle. Time will tell. Now this slide is a depiction of, again, pre-treatment versus end-of-season measurements of canopy frequency of Sericea lespedeza. We're looking down into a 12-inch square canopy and identifying Sericea plants, one or multiple, that appear in that canopy. And because our year effect is not significant, what you're looking at is the accumulated effects of treatment. What I can tell you is that before we began the project, that canopy frequency of Sericea lespedeza in all units was 36%, all treatments equivalent. Okay, and after 1 year of treatment, looking at our July 16th measurement, we're starting to see a trend anyway for a decrease in the appearance of Sericea in the plant canopies. And at the end of the season, okay, we're getting a decrease of roughly 50% canopy frequency with our early burn to about 25%. With our midsummer burn, that's approaching significance right there. The p-value was 0.06. And we're getting about a five-fold decrease in canopy frequency with our latest application of fire there in early September. Very encouraged by this information. Okay, other things that we're looking at in this analysis are things that we hope will give us some insight into how the robustness of Sericea lespedeza is being affected by growing season fire. Over 2 years of treatment, we have not had any initial indication that we are causing plant crowns to regress in their maturity. Okay, all treatments are equal. But at the end of 2 years, old growth Sericea lespedeza crowns appear with about a 35% frequency in our spring burn treatments, and they've all but disappeared, okay, in our mid and late summer treatments. Now, what significance, you might wonder, does this have? Crown maturity ought to be reflective of photosynthetic capability. Okay, and a plant that has some senescent material in it, has multiple stems that are growing from a single crown, is probably capable of maximizing root carbohydrate reserves prior to dormancy, and in effect channeling those carbohydrate reserves into current or subsequent season seed production. When a plant is immature, when there's just a single stem from one plant crown, or when there's no evidence of senescent material, its photosynthetic capabilities and its carbohydrate manufacturing capabilities have got to be depressed to some degree. We saw the same trend in looking at stem height. And what we do with this technique is that in every plot we measure, if we detect a Sericea plant, we'll get a height from ground level up to the top of the plant, and just comparing those maximum plant heights between treatments. Now, again, after 2 years of treatment, we've not been able to show an effect on stem height for either of our summertime burn periods relative to the spring burn period. However, okay, at the end of the season, okay, the maximum stem height in the spring burn treatments right around 27 centimeters. In the midsummer treatment, the average stem height is about 7 centimeters, and in the late summer burn treatment, the average stem height is about 2 centimeters. Referring this back to plant maturity, I think these two things together can be interpreted as indicating that fire during the growing season is having some effect on the vigor of Sericea lespedeza. Now, this is a neat thing about fire, folks. In my career, we've looked at herbicide treatments for Sericea, and we've looked at animal grazing treatments for Sericea. And one thing that I can conclude from all that work is that human beings on a spray rig will visually miss Sericea plants and they won't get sprayed. Animals that are grazing will, with their senses, miss Sericea plants and they won't get grazed. Looking at this right-hand panel, okay, where my pointer is located, you can see very clearly that there is a fire line there, okay, where we put the fire out to control it. Fire sees everything, folks. It does not miss a trick. Every plant in the path of that fire is going to be influenced by the path of that fire. Sericea lespedeza included. I saved the best for last here, folks. I think the two best indicators that we have for control and also for a decrease in Sericea lespedeza vigor are, physically, how robust is the Sericea lespedeza plants? Are they robust in each of these treatments based on their physical size, and how much seed do they produce? In this graphic, we're looking at whole plant dry weight at dormancy. So 100 random plants are plucked near our transect. They're dried down and they're weighed. We're clipping these plants at soil height, making sure that we don't contaminate them with soil, and just getting a gross weight on these plants. In our conventional spring burn treatment, the average plant weighed 3,100 milligrams. Okay, in our midsummer treatment, the plant that we harvested weighed about 450 milligrams, a 7-fold decrease in whole plant dry weight. And in our late summer treatment, the average weighed about 175 milligrams per individual. That's about a 17-fold decrease relative to the early spring treatment. Okay, and this one excites me most of all. Okay, in our early spring treatment, without any other Sericea lespedeza mitigation means or methods employed, the average plant in the early spring fire treatment yielded about 510 seeds per individual plant. For our fires that were conducted about August 1st, the average plant yielded 27 seeds. That's 27 seeds per plant for a 19-fold decrease relative to early spring. And in late summer, well, that number is not zero, okay, but it is essentially zero. The average plant in those treatments yielded 0.7 seeds per plant for a 700-fold decrease relative to the early spring burn. That, folks, excites me. Okay, some concluding remarks. I guess everybody's got to make them. But from the standpoint of concern that our ranching community expressed to us, if they were to use fire as a routine means of Sericea lespedeza control, they were not particularly interested in giving up dormant season grazing opportunities. Well, what I can say is, yes, there is some decrease relative to treatments that were unburned during the growing season, but going into dormancy, okay, all of our treatments had at least 3,500 pounds of forage dry matter per acre. And that would provide not an unlimited, but an ample grazing opportunity for those fall and winter months. Point two, our midsummer prescribed fire that was conducted around August 1st, we numerically reduced canopy frequency of Sericea lespedeza at dormancy. Okay, that just missed significance here at 0.07, or excuse me, 0.06, and resulted in a numeric 20% decrease, 29.2% canopy frequency for the August 1st fire, and 49.7% canopy frequency for the March 21st fire. Our late summer fires did a little bit better than that. Canopy frequency of Sericea lespedeza at dormancy was decreased 5-fold relative to that conventional early spring burn. Very encouraged by that information. More conclusions, things we can say about the vigor of Sericea lespedeza in these mid and late summer burns compared to the early spring burn. We have a decrease in incidence of mature Sericea lespedeza crowns. That's at least 30-fold. We have a decrease in stem height, maximum stem height of Sericea lespedeza, that's at least 5-fold. We have an incidence of multiple stem canopies decreasing about 30% in that comparison. And we have whole plant dry matter weight decreased about 7-fold, or at least 7-fold, in the mid and late burns compared to the early spring burn. Okay, seed suppression is probably a key to this study, a key to controlling the invasive qualities of the plant. Our midsummer burn plants produced 27 seeds per individual. Our spring burn plants produced 507 seeds per individual for a 20-fold decrease in seed production for that August 1st fire. Our late summer fire, we can't say that seed production was eliminated, but we're down to less than 1 seed per plant on those watersheds that were burned around September 1st, compared to 507 seeds per plant on those watersheds that were burned at the conventional time. Now, I mentioned this earlier, but a fire will, as it sweeps through an area, is going to affect every plant that it comes in contact with. And from that standpoint, it appears that growing season fires may be a comprehensive means to control the propagation of Sericea lespedeza. Another issue that's worth mentioning here is that by my calculations, the current cash cost of burning is about 75 cents an acre, not including insurance, whereas current cost of chemical is between $8 and $16 an acre, estimated fairly conservatively. So not only does burning appear viable and effective, it's a lot less expensive than what we're used to using. We're unsure and cannot conclude at this time how these growing season burns will influence forage species composition, soil cover, and forage biomass, but we intend to follow up. During the first 2 years of our study, we haven't had any indication of a negative effect on these properties, but we intend to go a couple years longer and find out if we can detect anything that's negative associated with these treatments. Now, other reasons why this approach to Sericea lespedeza control is either feasible or it just plain makes sense. At least from a temporal standpoint, this treatment is compatible with existing grazing practices, particularly intensive early stocking. Okay, in this scenario that we're projecting, the fires to control woody invasion and to maybe influence diet selection by grazing animals are lit after the steers leave rather than before they show up. We do not know what implications this may have on animal performance. I'm willing to concede that we may be giving up a little bit of that extra gain that we normally get with a spring fire, but if we can save $19 to $39 per hectare in chemical costs by using this treatment relative to burning, we may be able to afford to give up a little bit of that extra animal performance. This is an area that, as a researcher, I'd like to take a crack at. I'm currently trying to locate some grant money to study that question. Smoke management, okay, is something that in the last 3 or 4 years we've all learned the definition of, and we're learning that we have to be courteous to our upwind neighbors as prescribed fire managers. If we can move some acres in the Flint Hills or the Osage Hills out of that conventional window of burning time and move that to late summer, we may decrease our incidence of air quality problems. It's worth mentioning in this context. Last point today, I don't know of a single rancher that isn't overworked and stretched a little thin during the spring months. They're receiving their transient yearling cattle at that time. They may be also calving cow-calf pairs. There's a lot of things to do, and in adding prescribed burn application to that spring window of time is just overload. If at least a portion of any individual ranch's acres can be moved outside of that conventional window of time into a period of time when the workload is more manageable, we may see some improvements in time and labor management for our ranching clientele. Okay, last thing I want to leave you with, just kind of a fun thing. This area here in the foreground that's a little bit deeper green right here is one of our August 1st burn units here. And just across the fence, this is the neighbor. I know you can't voice in here, but I know you're all thinking, what is this red stuff over here? Well, obviously that's smooth sumac. Prior to the application of fire on this side of the fence, um, that cluster of smooth sumac plants extended down this slope and well into this draw. This photo was taken just 1 year after our treatments began, so just one growing season fire. There's a beautiful fence line contrast there that just kind of illustrates one of the additional benefits of growing season fire application. This one burned in the spring. No real change to the smooth sumac population. This first, and it's tough to detect a sumac plant across that fence line. Okay, that concludes my my presentation here, folks. Again, thank you very much for taking your time to be with me this afternoon, and I'd be happy to try and answer any questions if there are any.
Thank you, Casey. I think you're the first person I've ever heard get excited about Sericea control. That's pretty awesome. So
That is my life, Sherry.
well, I think a lot of people are going to be grateful that you are. So if anybody has any questions, we do have one already. Feel free to type it in the chat box, and we'll try to get to you as soon as we can. And so, Casey, do you want to go? Do you want me to read those questions for you, or do you want to handle
I can
those?
see them, Sherry. I
Okay.
can see them, and I can repeat them for the folks. Question from Gene says the decrease in seeds per plant is impressive, but does the late season burn seed production include what might have already been dispersed earlier in that season? That's a great question. And one of the things that I've observed with Sericea over the course of the last 3 years is that seed production and seed drop is highly seasonal. There's a process of maturation that the seed goes through that begins maybe in late August and does not conclude until very nearly that first killing frost. For example, if you pluck seeds off of an individual plant before those seeds are fully mature, it's almost like handling wheat in the dough stage. The seeds are easily crushed, and I don't believe they would be patent, would yield a plant were they to even be able to germinate. Now, one of the things that I didn't mention because I don't really have any data, but it's interesting, is that the seeds that we have collected off of our summer burn treatments do not appear to be visually equivalent with the seeds that we've collected with our spring burn treatment. They're smaller and they're greener. We're not funded for this, but one of the things that we are going to do in the future, I hope, is to do a germination test on seeds that we've collected from each of these treatments. It would be worth knowing that, you know, even if seed is mature, is it still capable of germinating at the same rate? Okay, I'm just scrolling through and looking at the next question. The next one is, what stage were the plants semicolon blooming or already starting seed production? Well, it really depends on where we took the measurement. Our initial measurements in mid-July, the plants are completely vegetative there. There are no flowers. There are no structures that could be interpreted as seed-bearing structures. That changes, okay? On an unimpeded plant, the process of flowering begins usually in late July or early September. Seed pods start to appear, and we don't do our final measurement of canopy frequency or our whole plant dry weight or our seed production until we've reached the dead end of the growing season. So the stage we collect these plants for whole plant dry matter weight and seed production in particular, they are just a skosh from dormancy. We've got to be really careful in when we do those collections, because once we get a hard killing frost, the plants become extremely brittle and seed dispersal becomes a real possibility. So we're out there every day during that interval of time and watching the plants to see when just the right harvest point might be. Okay, next question. And I'm being asked to speculate here a little bit, but late season burn effects on oak seedlings and open oak savanna, question mark. We don't have, oak are not part of the our plant inventory on this particular site. So I can't speak to oak specifically, but year on year there wasn't any change in the basal frequency of woody stem plants in any of our treatments. Visually though, along the margins of our treated area, you recall there's a big woody draw that runs through the center of the treated area. Where fire touches any robust woody stem plant, including trees that are 10 to 40 feet tall, fire tends to be very hard on them. So whether you're interested in managing for the oak or against the oak, my opinion would be that fire contacts an oak seedling in an open savanna or semi-open savanna like this, it's probably going to kill it. Next question, any effects on blackberry invasion? Blackberry, again, was not something that was detectable in our plant inventory. So I can't speak specifically to that species. But one of the interesting things about blackberry is its growth form. It's blackberry produces a very dense stand. There's very little fuel in the understory, and it's sometimes difficult to get fire to travel, to carry through an exceptionally large blackberry stand. But again, in an area where there is a heavy Sericea lespedeza canopy, okay, you get something very similar to blackberry going on in the understory. With the allelopathic properties of Sericea, there's very little competing plant matter in the understory. Consequently, there's very little duff. But when a fire gets into a dense Sericea stand, it's really something to listen to. There's all this crackling and popping. It's a very noisy affair. But the fire will, with very little coaxing, in some cases no coaxing at all, the fire will transit that thick Sericea lespedeza stand completely. And what you'll be looking at immediately post-fire are a bunch of standing green stands with blackened earth, or standing green plants rather, with blackened earth all around them. You come back 48 hours later, all those standing green plants are brown and dead. And they do not, from that same stem, do not regenerate any green growth. Okay, next question. Is the respective treatment conducted on a pasture each year, or with what frequency is conducted? Answer to that is yes, the treatments are fixed. So if a particular watershed unit is assigned to a spring burn every year, it's going to get that spring burn every single time we apply treatments. And likewise with the later burns. Next question. These results coincide with the season of burn plots at OSU. The September-October plots have the least amount of woody plants. So thank you for that echo of hope. Next question. Does the decrease in vigor seen at the end of the season, or is it carried into the next year? And I'll answer that with a visual. You can still see my slides, right?
Yes, we can.
Okay, good. Now, year was not a significant effect in our statistical model. So the rules, according to Hoyle, say that I have to show you the highest order interaction in our analysis, and in that case, that was treatment by time. The fact that year was not a significant effector of our treatment responses is actually a fairly positive thing. But what you're looking at here, let me get my pointer so you can see what I'm referring to. What you're looking at here for July 16th, the July 16th measurement averaged over 2 years, okay, one before any treatment was applied, and one measurement after all treatments had been applied one time. because you're starting to see a numeric trend for a decrease. And when we pull that all the way through to the point of plant dormancy, we're actually getting some statistical differences between our treatments here. What I anticipate, okay, is that as the timeline of this study plays out, okay, that our most dramatic effects on canopy frequency and other indices of plant vigor are going to start asserting themselves in this interval of time right here. Because what we want is to be able to demonstrate eventually that the accumulative effect of multiple years of growing season fire has a significant depressive effect on these indices of Sericea lespedeza vigor. Now that brings me to the end of the list of questions. If there are any more, please fire them off.
Casey, would you mind typing your email address or whatever contact you prefer if people want to follow up with you individually?
Okay, and I do that below the chat dialog box?
Yep, just in the window below where you're reading the questions.
Okay.
There you go. And there's one more question did pop up.
Okay, I see it there. Are these patches being burned each year? The answer to that is yes. Treatment is fixed, but we plan to do 4 full cycles of these treatments.
And Casey, I was wondering, and I know there's like an endless amount of variations that you can do with this study, but and maybe the OSU work already kind of gives us an answer to this, but I was thinking about the study you're doing is just looking at fire. It's not including a grazing treatment. So I'm wondering about.
The whole area is grazed, but nothing gets grazed. None of the area is grazed after the 15th of July in this case.
Okay. Thanks for that clarification. Okay, I think we got one more question typing in, and then we'll cut everybody loose. And Casey, I want to thank you for braving through the ice storm there in Kansas to be with us today. We had a pretty robust audience, and so I know there's a lot of interest, and so I think everyone really appreciated you making the extra effort to speak to us today.
It's my pleasure. Thanks for the opportunity. And that last question is here. And I'll read it. Is there any sense of whether there is an increase in native warm season grasses? And I'll take you back to, I guess, a preliminary indication. Okay, this is as good a place to start the explanation as any. We may be seeing a trend toward a reduction in bare soil with our growing season bird treatments relative to our early season treatment. Moving on to the subsequent slide, we appear to have better litter cover on our summer burn treatments compared to our spring burn treatment. Again, that may be a real trend, that may be just a numerical artifact. But in looking at plant cover, I mean, the first thing we were concerned about is would we have a negative influence on plant cover that's driven by treatment or by year. You know, there's a little bit of noise here, but I would say that for the most part, there's no strong indication here that we're changing plant cover, total plant cover, either positively or negatively. When I look at individual plant species, and granted this data is very messy at this point, year on year, we had numerical increases in Indian grass, big blue stem, little blue stem, Cytotes, grama, the good ones, and also numerical increases in tall drop seed, one of the bad ones. So whether that affects, or whether that is due to treatment, or whether that was due to the fact that year 1 was really dry and year 2 was really wet, I can't say at this point. The only conclusion I can draw is that we cannot detect any negative influences on total plant cover at this point.
All right, Casey, thank you very much. And I will be posting the recording of this webinar on the Great Plains Fire Science Exchange YouTube site. So if any of you would like to share this with your coworkers or other interested folks, you'll be able to find it there. And Casey, if you're able to get some of the work that you've described published, I'd love to post it together with the recording of the webinar so people can easily access the whole suite of material you have available.
I would be happy to forward what I have published thus far.
Great. Appreciate that. And our next webinar will be very soon, looking at juniper pollen